Alright, class. We are beginning a unit on Python, and Python, I briefly showed you a little bit of it in class the other day, but Python is just another programming language. Like processing, it's actually a fairly easy to learn language, which is why we're going to do it. It's also a language that you'll see a lot of the Raspberry Pi projects use that. Python comes standard on the Raspberry Pi, and so it's something we'll be using. We won't be doing nearly as much in depth on it as we did in processing, but a lot of the same principles apply. A lot of the same things that we did in processing apply in Python as well. Some things maybe you'll find are a little easier and you like better. Other things maybe you'll find them harder or whatnot. And normally we would start this lab on our Raspberry Pi. However, I'm gone, and I also thought it would be useful to try it out here for a second on our Macs. So you have Python actually built in, and I think I briefly showed you that. And so I'm going to walk through the first little bit of this lab with you and how you're going to do it on your computer. You're actually going to be doing it pretty much all in Terminal. So if you don't have Terminal open, might not be a bad time to open it up. I'm actually going to make that full screen so I can swap back and forth here. I guess before we even get started here, we should probably have a place to save our Python files. So I'm going to go into my documents. And I actually, if I do a list here, you'll actually see I actually have a Python folder already. If you don't have a Python folder, I would encourage you to make one. mkdir, that's make directory, Python. I'll make mine Python 1 for our class example here. So I make a directory, and then I'm going to open that directory. I'm going to change directory and go to it. And you'll notice, you can see down here, we're in Python 1 now. And of course, there's nothing in that right now. But we are going to make a program, and we're actually just going to do this like old school, and we're going to use the text editor that's built into the terminal. We're going to use Nano. So Nano, and we're going to create the first lab here is like a little math program. Do not title your program math. If you do that, it's going to screw things up. I'll just leave it at that for now. So I'm going to call mine, math program, all one word, .py. So I'm going to create a new file in Nano, and I get this blank text editor. The very first thing that we need to do is there is a library, a math library, that gives us access to a lot of functions like cosine and sine and the variable pi and exponential growth and yada yada. And so we're going to need that. And so if we need a library that's got a whole bunch of stuff built in, we actually have to import it. So I'm going to import math. This is why I didn't title the program math, because then it would get confused with whether I'm importing the library math or if I'm just trying to import the program that already exists there. So anyway, I'm importing math. And then the most basic of commands is this print command. I actually put print with parentheses. Different versions of Python have slightly different syntax. In ours, you can actually, I think, just do print. And I don't even think you have to put it in parentheses, just print what you want it to print. So print, welcome to my math program. I'm actually going to stop here for a second because I want to constantly check and make sure this works. So I hit Control X. You'll see down here that exit is Control X. So I'll hit Control X, and it's going to ask, do I want to save what I've put in there? Yes. And what do I want a file name? I want it to be the math program 1, so I'm going to hit Enter. And now, if I hit LS, you'll see I've got that math program in there. Now to run it, I just do Python mathprogram.py. Hey, it works. It says welcome to my math program, but that's all it did. It didn't give me any error messages, so that's a good sign. So now I will go back in Nano Math Program, and I will add a few more things to it. The next thing, it says I need to give my my user some instructions. And so if you scroll down a little further, like you're going to create a math program that's going to do addition, subtraction, etc. So we'll just do the addition one here, but they're first going to have to actually enter a choice, but they have to know what their list of choices are. So every time you do a new print line, it's going to write it, or new print command, it's going to do it on a new line, so we don't have to worry about that. So print, what is it going to print? I don't know. Options. And then print, and then we'll say option 1 is addition. And later I'll come back and I'll say, have like print 2 is subtraction. And I'll actually exit this just a second, save it, yes, and just quick test it, make sure it's working, and see how it says, welcome to my math program, options 1, addition, subtraction, etc. Perfect. The next step, after I've given the user some instructions, is they actually need to input a choice. So we're going to create a variable called choice. Nice thing is here, I don't actually have to, like, at the beginning of my program, pre-declare what kind of variable this is. I can just call it choice. And it's going to equal whatever the user inputs. But I also want to give a little bit of a command to the user here, so enter your choice. So that will be the prompt for the user to enter his or her choice. I think I'm actually going to put just a blank print command in here as well. So save it quick a second, double check, see if it's working. See, look, it says welcome to my math program, options 1 addition, 2 subtraction. I can enter something, and of course it doesn't do anything because I haven't given it any more commands. But yeah, it works. So that was my prompt that it puts up, and then it stores whatever the user inputs as the variable choice. So what next? Well, I might want to convert it to like an integer, because right now it's naturally going to store it as a string. So I'm actually going to come back to my choice here, and I'm going to use that int command to actually turn it into an integer. Oops, I can go like that. Put both my parentheses in, and so now it will convert it to an integer. And now I can do my simple if statement. If function works very similar to before. If. I don't think I need parentheses. We'll try it. Pretty sure I don't need it. Anyway, if choice equals 1, then I put a colon, and now everything that I want it to do if choice equals 1, I have to tab in. There's none of these curly braces, it's just everything is based off of tabbing it in. So everything that gets tabbed in underneath it is going to be stored there. And so I'm going to do something very similar that I did before, where I'm going to create a variable called x, and I'm going to want the user to be able to input it. And so I'll store x as, and I do want to store it as a float, so like I did with the choice, storing it as an integer, I'm going to convert it here to a float. So input, and this is that prompt, enter, I'll do it the way I have it in the notes there, enter x, and then I'll close my parentheses, and I'll do the same thing with my y. It'll equal float, and the user is going to input it. There we go. And then lastly, I want it to print. And I want it to actually print out, I kind of want it to print out the whole equation here. So it's going to print out my x, whatever that x is that the user inputted. And then I put comma to kind of combine these things that I'm going to put in my statement. And I want it to print out the plus sign, and then the y, and then notice a comma again in between each of these things. And then I want it to print out the equal sign, and then I actually want it to print out x plus y, the variable that what it actually adds up to. Let's try that. So now I'm going to run my program. Control X, save it. Yes, math program. By the way, if you hit up and down arrows, you can go to your previous commands that you typed in. So that's how I do it so quickly. So anyway, Python math program.py, enter my choice, 1, enter an x, 3, enter a y, 5, it prints out 3 plus 5 equals 8. Wow, it works. Your job then is going to be to create more options for subtraction, division, multiplication, circumference of a circle, etc. So you're going to have to go into your thing, math program here, and you're going to have, well now, if choice equals 2, what is it going to do? It's probably going to be pretty similar. I did want to show one other thing, why we imported the math. So maybe I'll make my choice, just again, do yours, I guess probably in the order that we did it, but I'm going to do circumference, just so that you can see how that's done. So if they choose circumference, same as before, I tab over and they're going to enter a radius, so I'll say r equals float input enter radius. And then it's going to print circumference. There we go. And now it's got to actually calculate it. Well, what's the formula for circumference? I believe it is 2 times pi. I could put 3.14159265535, etc., etc. But because I imported that math up here, remember I imported this math module, I can actually type in math.pi because it stores math.pi. So 2 times pi, how I access that pi variable inside the math is just math.pi. You've seen that syntax when we used classes in processing. So 2 times math.pi times r, because that was the radius that we inputted, 2 pi r. Okay, that was simple enough. Exit. Yes, I'll save it. Yes, I'll save it. And let's just test it a second. So 2, enter my radius of 5. Says circumference is 31.415, etc., etc. Which makes sense. So there you go. I think that's enough to get you started. You're going to create that file. Eventually you're going to turn it in, and you'll notice that I actually have that file sitting right here. There's that math program. That's the one that you will ultimately submit to me. When you're finished, email me that Python file. So have fun, and I will see you guys when I get back.